Welcome to this explainer. Today we're taking you on a complete journey from absolute beginner all the way to mastering the modern generative AI landscape. Look, whether you're a student, a software developer, or really just an AI enthusiast who wants a clear, structured path to building with this tech, you are in exactly the right place. We're going to break down what generative AI actually is. We'll pop the hood to see how large language models work, and then we're giving you the exact blueprint to becoming a highly paid AI engineer. Let's dive in.
Because right now, the demand in the job market is absolutely exploding. Get this, according to recent reports, for every 10 open generative AI roles, there is only one qualified engineer available. Seriously, let that sink in for a second. We hear all this chatter about AI taking jobs, but the reality on the ground in the tech sector is a massive talent shortage. Companies are desperately hunting for hybrid experts, people who can build models, integrate APIs, and actually deploy these systems at scale. This gap between supply and demand, it's a massive, golden opportunity if you're willing to put in the focus.
So, here's our game plan for today. We'll quickly trace the evolution of AI, look inside the generative engine itself, learn how to control these models, explore real-world agentic applications, and wrap up with your 6-month engineering roadmap. Okay, part 1. The evolution of AI, from rules to reasoning.
We didn't just wake up one morning with these near-godlike AI capabilities, right? This has been evolving for decades. Back in the 1950s, up through the 80s, we basically just had rule-based AI. Think of an old-school customer support phone menu. Press 1 for billing, press 2 for support. It was rigid. It only did exactly what it was programmed to do. Then the 1980s hit, and machine learning emerged, letting systems actually learn patterns from data instead of just blindly following instructions. Fast forward to the 2010s, deep learning gave us complex neural networks for things like advanced image recognition. And that perfectly set the stage for where we are right now in the 2020s, the era of generative AI.
To really understand this shift, think of it like this. Traditional machine learning was essentially your data analyst. Its all job was to predict or classify existing data. It looks at a message and asks, okay, is this spam or not? But generative AI is the artist. Instead of classifying things, it creates entirely new content from thin air. So instead of just catching a spam email, you can prompt a generative AI to write a highly professional email to a furious client, and it literally generates it from scratch. Going from prediction to generation is easily one of the most massive leaps in tech history.
Moving on to part 2, inside the generative engine. Let's demystify these large language models.
So, if we want to look under the hood of models like ChatGPT, Claude, or Gemini to see how they actually pull this off, you have to realize one mind-blowing fact. AI does not read English words the way you and I do. Honestly, it doesn't even know what the alphabet is. Before a model can process any language, it chops your text into tiny little pieces called tokens. A token could be a full word, a piece of a word, or sometimes just a single character. The model reads your prompt one token at a time, and when it replies, it is literally building that response token by token.
And the engine doing all the heavy lifting here is the transformer architecture, which hit the scene back in 2017. Here's the magic trick in 3 steps. First, embeddings. This converts all those text tokens into huge lists of numbers so the computer can mathematically grasp what they mean. Second, transformer blocks. This is the secret sauce. The model uses a trick called self-attention to look at every single token in your prompt at once, figuring out how they all relate to each other to understand the deep, actual context. Third, output probabilities. The model calculates the mathematical odds of what the very next token should be, picks the winner, and repeats that whole process over and over to write out a sentence. At the end of the day, it's basically the world's most incredibly advanced next token prediction engine.
Which brings us to part 3, controlling and grounding LLMs, moving way beyond the basics.
Now, next token prediction is super cool, but if you leave an LLM entirely unsupervised, it might just confidently invent total garbage, which we call a hallucination. So, how do we fix that? The industry standard answer is RAG, or Retrieval-Augmented Generation. Basically, RAG grounds the model's answers with cold, hard facts. Instead of letting the AI guess purely on its older training data, a RAG pipeline intercepts your question, searches through your own external documents, like your company's secure database or a specific PDF, grabs the exact facts, and forces the model to use that real data to formulate its answer. It's like giving the AI an open book test, and it drastically reduces those hallucinations.
But to actually build these RAG pipelines and real enterprise apps, you're going to need a very specific toolbox. The modern AI engineer tech stack relies on foundational languages like Python and SQL. To connect and chain your models together, you'll be leaning on frameworks like LangChain and platforms like Hugging Face. You'll wire things up using the OpenAI API, and then for tracking your experiments and actually deploying your apps to the real world, you'll use MLOps tools like MLflow, Docker, and FastAPI. Just writing the algorithm isn't enough anymore. The engineers getting hired today are writing the entire end-to-end pipeline.
All right, part 4, real-world agentic applications. This is what happens when AI takes action.
See, the industry is already moving way past simple chatbots that just answer your questions. We are officially stepping into the era of Agentic AI, where models act on their own. Agentic systems work in this continuous autonomous loop. Step 1 is perception. The AI actively collects live data from the world around it, maybe from physical sensors, databases, or live APIs on the web. Step 2 is reasoning. It uses natural language processing to understand that data, spot patterns, and decide what action to take. It executes the action, checks the result, and decides what to do next, all without a human ever clicking a button.
And I know this sounds like sci-fi, but these agents are actively deployed in the real world right now. We've got AI trading bots reading live economic news and executing stock trades completely on their own. Over in healthcare, agents are monitoring live patient vitals and adjusting treatment recommendations on the fly. In cybersecurity, they're watching network traffic 24/7, spotting weird anomalies, and locking down threats before a human security analyst has even had their morning coffee. They're even out there autonomously reordering supplies to keep global supply chains moving.
Looking ahead at the landscape of models powering these agents into 2026, finding the best AI model entirely depends on the specific job you're doing. Google's Gemini 3.5 Pro is an absolute beast for deep reasoning and digesting massive amounts of text. Anthropic's Claude Opus 4.8 is widely considered the go-to for complex coding. OpenAI's GPT 5.5 is your ultimate all-rounder, especially when you need the AI to use external tools. And then you have these open-weight models, like Meta's Llama 4 and GLM 5.2, which are going toe-to-toe with the big guys, offering developers the huge perk of running the models locally to keep data private and slash costs.
Finally, part 5, your 6-month engineer roadmap, the exact path to getting hired.
If you want to actually build these systems and grab one of those incredibly high-demand jobs we talked about, here is your no-nonsense blueprint. First rule, do not skip the basics. Month 1 is all about foundations, mastering Python, pandas, and the math powering machine learning. Month 2, you move into practical ML, building classification pipelines and tuning algorithms. Month 3 introduces deep learning. This is where you build actual neural networks and wrap your head around gradient descent. Then, and only then, in month 4, you dive into generative AI. You learn transformers, prompt engineering, and you build your very first RAG pipelines using LangChain. Then we hit the final stretch. The last 2 months are all about bridging the gap between being a hobbyist and a true professional. Month 5 is heavily focused on MLOps. You learn to package your models cleanly using Docker and deploy them to the cloud as APIs using FastAPI. Finally, month 6 is your capstone project. You are going to build a comprehensive end-to-end Gen AI application. This could be an AI PDF research assistant or maybe an automated resume screener that ties together an LLM, a vector database, and a slick user interface. You need this to prove to employers that you can actually ship real working products.
And the financial payoff for sticking to this roadmap, it's huge. Because of that massive talent shortage we touched on earlier, salaries are out of this world right now. Globally, AI and machine learning engineers are averaging over $120,000. And in booming tech hubs like India, entry-level roles are starting between 5 and 12 lakhs per annum. Mid-level positions easily hit 20 LPA, and senior Gen AI architects are commanding up to 44 LPA. If you're willing to put your head down and do the 6 months of work, the opportunity here is literally life-changing. So, we've traced the evolution of AI. We've peeked inside the complex neural networks predicting that next token. We've learned how to ground them with real facts. And we've laid out your exact career roadmap. You now have the blueprint to go out and master generative AI. The technology is here, and trust me, the industry is waiting for you. So, the only question left for you to answer is, in a world where AI generates all the answers, what will you build?